AP Calculus AB, Unit 6, Day 3 office hours. So I did number 2 in the lesson. Number 1, so remember, if you can do this from memory, so we're based off this tangent lines. Euler's method is just repeat tangent lines. Y minus y1 equals m times x minus x1. Now y1 and x1 are the old known y values. And then the slope is based off those points too. And so this is going to be y minus y old equals y prime old x new minus x old. So this is y new. This is the new approximation we're trying to get. X new minus x old is usually constant delta x equal step sizes. So the table approach is just a streamlined way of doing this, but you got to know this stuff. This is how you would do it. Without the table, this is what the table is based off of. So we have an xy pair known. And it's going to be y new equals y old plus y prime old delta x. That's what's going to be up here. Y prime delta x is 1. We're going up 1 each time from 2 to 3 to 4 to 5. And delta x is the same. Now this is our formula for finding y prime. It's going to be 8. So it's going to be this. The new y is going to be the previous y plus y prime times delta x. So it's going to be that plus this times this. So that's going to be 14. You add them together to get the next derivative. The next one's going to be this plus this times this. I write this stuff down just to kind of make it solid in my head. It's 31. So this one, the new y prime is going to be 35. So the new y is going to be this plus this times this. So that's going to be 66. That's your final answer. Don't need to do y prime or delta x for the last step. Let's write our answer nicely. F of 5 is approximately 66. This is an estimation. We did number 2. This is the work, in case you missed it. Pause the video if you need to. Number 3, I'm going to try and use the same technique. X, y prime, delta x. This is y new equals y old plus y prime old delta x, which comes from the tangent line, which comes from point slope form. So we're starting at 4, 2. Step size is a 0.2. So the next one's going to be 4.2. Next one's going to be 4.4. Next one's going to be 4.6. 0.2, 0.2, 0.2. Okay, so the derivative, so the new y value is always going to be the previous y value plus the derivative times delta x. This is where it comes from, okay? And I worked that out up here from just writing the equation of a line, tangent line, and point slope form started with. So we got to do 2 times 4 is 8 plus 2 times 4 is 8 minus 2 is 6. New one's going to be this plus this times this. Now it's going to be 1.2, so it's going to be 3.2. And so it's going to be 2 times x, 8.4 minus 3.2, 8.4 minus 3.2 is going to be 5.2. It's going to be this plus this times this. So that's going to be 10.4, but you move the decimal point, so it's going to be 1.04. So it's going to be 4.24. And then 2 times this, it's going to be 8.8 minus 4.24. It's going to be 4.56. So it's going to be this plus this times this. So this is going to be 8, 9.12. 9.12, but then you got to move the decimal point to the right one. You add these together, and you get 5 point. It's going to be 2, 5, 11 carry the 1 to 4 is 5.125. Final answer, let's write it nice, 5.46 is approximately 5.152. Don't need the last y prime, don't need the last delta x. So that's what we're doing here. So number 4, we're going to do 2 ways, the approximation way and then the exact way. So I'm going to try and leave myself some room. So the initial value is 2, 1. Delta x is 0.5, and we're going to get all the way to 3, so it's going to be 2.5, and then 3, and then we'll be done. So the derivative is xy, so that's going to be 2. So the next y is going to be the previous y plus derivative times delta x. It's going to be 2. And you multiply these together to get the derivative. It's going to be this plus this times this. It's going to be 4.5. So the approximation for f of 3 with Euler's method, 2 steps, is 4.5. Now, the exact approach is to solve the differential equation like we've been doing. So this was part A. Part B, you're going to separate the variables. dy over y equals x dx. Natural log of the absolute value of y equals x squared over 2 plus c. Let's find the c value. Natural log of 1 equals 2 squared over 2 plus c. This is going to be 0. So c is going to equal -2. So natural log of the absolute value of y equals x squared over 2 minus 2. I'm going to exponentiate both sides. Get rid of the absolute value, plus or minus. E to the x squared over 2 minus 2 is all in the exponent. Now, if I plug 2 in, I would get e to 0, which is 1. I want it to be positive 1, so it's going to be positive. So the exact solution is this. Now, to get the exact value for f of 3, you're going to plug 3 into this. And we could simplify this a little bit. It's going to be e to the 5 halves is the exact value of f of 3. Now, on a calculator, we could figure out what that is, and it comes out to 12.182. So, not super close to our estimate, but if we broke this down into more steps, like 10 steps, it'd probably start to get closer. Error would be less. Okay, these ones are pretty much set up for you, partly. The delta x, you might have to find yourself just from the table over here. So the new y value is going to be the previous one plus the derivative times delta x. So that's going to be 13. This one's going to be this plus this times this. So it's going to be 15. This one's going to be this plus this times this. It's going to be 17.5. So the one thing that's being done for you are the derivatives, which a lot of times are a bit of the work. So f of 2.5 is approximately 17.5. Okay. Next one, add the delta x ourselves. Here's the delta x equals 1. Equal step size is 1, 1, 1, 1. The new y is going to be the old y plus the derivative times delta x. So I like to put that stuff in my work just to remind me. It's going to be 9. Next one's going to be this plus this times this. That's going to be 7. Next one's going to be this plus this times this. 14 is your answer. So f of 5 is approximately 14. I don't need to worry about number 7. And so that is it. There is another worksheet that you can work on, assignment 3B, some multiple choice stuff. I'll make a separate video for that. Hopefully you're starting to get the hang of Euler's method.